Hello everyone, welcome once again to another career roadmap related tutorial by Team Slidescope. In this part we are discussing about roadmap to become a data platform engineer. So here you can see a small diagram here. In this diagram you have 10 steps. So you start by understanding the data ecosystem first if you want to become a data platform engineer, and then you follow these steps. Let's discuss. So data is the lifeblood of the digital economy. Every decision, every recommendation, and every forecast depends on the quality and accessibility of data. But behind every seamless data-driven process stands a professional who ensures that this data is available, reliable, secure, and scalable. This is the data platform engineer. So if you have ever wondered how to start a career in this domain or how to transition from a data analyst or software developer role, this guide will walk you through the 10 essential steps to becoming a successful data platform engineer. First is understand the data ecosystem. Before diving into tools and technologies, it is important to understand the ecosystem you will be working in. Data doesn't just appear, it's collected, processed, stored, and transformed across multiple systems before it reaches analysts or business users. Learn how to learn how different systems interact, from transactional databases to data lakes, ETL processes, and analytics dashboards. You should be able to visualize the data flow from raw injection, that is API sensors files, to the final analytical reports in Power BI, Tableau, or Looker. Tip is to study architectures like modern data stack, data mesh, and data fabric. They will give you clarity on how enterprise organize large-scale data operations today. Second part will be master SQL and database fundamentals. No matter how advanced data engineering becomes, SQL remains its backbone. A data platform engineer must write efficient queries, design schemas, and ensure optimal performance for both transactional, that is OLTP, and analytical, that is OLAP systems. You can start with basic like select, join, and group by, and gradually move to stored procedures, window functions, and query optimization. Understand how indexing, normalization, and caching works. Hands-on practice is key. Set up your own PostgreSQL or MySQL instance and experiment with real datasets. So if you want to get started, you can start with websites like freedb.tech. At the time of creation of this video in 2025 October, this website is up and running and it will provide you free database. It provides you an online PHP MyAdmin interface, or you can install XAMPP or AMP in your system and you can run. So here you can see we have an interface, and in this interface you can see you can log in here with this server and these credentials, and you will be able to create and operate databases quickly. You don't have to install any separate application in your computer. So you can see we have an interface. A complete tutorial for this is there on our channel itself. If you want, you can comment and I will provide you the links, and I will provide some links anyway in the description. Here you can see we have some databases. We even have this designer where you can learn how different tables are connected with each other. So you can see we have different tables and you can learn how to connect them. If you view in full screen, you will be able to learn how your data model is. So these type of databases, these type of SQL databases will help you in understanding the basics, and this will cover mastering SQL and database fundamentals. We have a dedicated course related to SQL on our Udemy profile. I will provide that link in description also. You can enroll in that course as well if you need to learn these things. A professional tip is explore cloud native databases also, such as Amazon Redshift, Google BigQuery, or Azure Synapse. They are integral to modern platforms. So you will start with something more traditional like PostgreSQL and MySQL, and then you will explore cloud native databases. Then you need to learn a programming language for data engineering. While SQL handles querying, you will need a scripting or programming language to automate and orchestrate data flows. And Python is the most preferred choice. It integrates seamlessly with APIs, data sources, and cloud platforms. Learn libraries like Pandas for data transformation and SQL Alchemy for database connections and PySpark for big data processing. On our other website, you will find Python programming tutorials. You will find Python Pandas tutorial, Matplotlib tutorial. These are all step-by-step tutorials that you can see here, and these will help you in understanding these concepts easily. So you have to understand that. So I will provide these links also. Whatever I am providing, I will provide you resources also where you can get started and learn things. So learning a programming language is very important. Then you should understand data modeling and architecture. Designing efficient data models is both an art and a science. You must understand how to structure data for analytical speed, scalability, and storage optimization. We saw a simple ER diagram or that you just saw in the MySQL interface. So you have to learn data modeling. Start with basics of dimensional modeling, that is, what are facts, what are dimensions, and what are hierarchies. Learn how star and snowflake schemas are designed. These videos are already there on our channel. Also explore data normalization versus denormalization, data marts, and OLAP cubes. This knowledge helps you ensure your platform supports accurate and fast business reporting. Example is in retail dataset, a sales fact table may connect to customer, product, time dimension tables. This structure powers dashboards and KPI analysis efficiently. This is a very simple Power BI interface. This is a Power BI dashboard. If you will go to model view, you will be able to see a very basic model where we have a sales pipeline table, products, accounts, and sales teams. And these lines are representing how different tables are connected, like account in both these two tables are common, product ID in these two tables are common. So you will see what common values are there in your tables and how to link them. And we have more than 200 such videos where you will be able to see how data modeling is done, how basic data modeling is done. And then once you will have this understanding, then you can perform data modeling on any big data set also with probably more than 100 tables also. So understanding data modeling and architecture is important, and we have tutorials where we have discussed about fact tables, dimensions, etc. After understanding data modeling, gets hands-on with cloud platforms. This is important. You can pick one cloud provider and go deep in it. AWS, which is which is by Amazon, you can learn S3, Glue, Athena, Redshift, and Lambda. If you are going with Azure, you can explore Data Lake, Synapse Analytics, and Data Factory. If you are going with Google Cloud, you can practice BigQuery, Dataflow, and Dataproc. You should understand data security, scalability, and cost optimization. You can get a certification like AWS Certified Data Engineer or Azure Data Engineer Associate, and this adds huge credibility to your profile. A professional tip is learn how data is stored in object storage, moved via pipelines, and queried in data warehouses. So get to know these different elements. Then you must learn big data technologies once you have hands-on with cloud platforms. Enterprises often deal with petabytes of data flowing in real time. To manage this, you need to understand big data ecosystems. You can start with Apache Hadoop, which introduced distributed storage and processing. Then move to Apache Spark, the industry standard for large scale data computation, and you can learn Apache Kafka for real time data streaming. Big data frameworks help process structured and unstructured data efficiently. Example is a data platform engineer at Netflix might use Kafka to stream real-time user activity data into Spark, which processes it before insights in S3 for analytics. Sorry for noise. Then you can build ETL and ELT platforms or pipelines. Your main responsibility will be ensuring that data flows smoothly across systems. This means building reliable ETL, that is extract, transform, load, or ELT, that is extract, load and transform pipelines. Some tools are Apache Airflow, which is for workflow orchestration. Then we have DBT, which is for data transformation, or Azure Data Factory or AWS Glue for data integration. What ELT means, what ETL means, if you want to go in their basics, we have separate videos for them. You will handle scheduling, dependency management, and error recovery. Learn about incremental loading, data validation, and monitoring. Your goal will be able to automate daily data ingestion from multiple sources, APIs, CSVs, and databases into warehouse. Then point 8 is master data governance, security, and compliance. With great data power comes great responsibility. You must ensure that the data platform complies with governance and privacy rules. Understand data lineage, cataloging, and metadata management. These concepts help you track where data comes from, and how it is used. Security is equally critical. Implement IAM roles, data masking, encryption, and access controls. These are terms that you need to study. Regulatory frameworks are also there, so familiarize yourself with GDPR, CCPA, and HIPAA, especially if you work with users or healthcare data. A well-governed data platform ensures trust and transparency across the organization. Point 9 is to implement CI/CD and infrastructure as code. Modern data teams align with DevOps practices. Automation ensures scalability and stability. Learn to build CI/CD pipelines using tools like GitHub Actions, Azure DevOps, or Jenkins to automate code deployment. Also explore infrastructure as code, that is IAC, using Terraform, AWS CloudFormation, or Azure Bicep. This allows you to deploy data infrastructure consistently across environments. One tip is containerization. Tools like Docker or Kubernetes are essential for scalable, portable data services. Point 10 is to develop observability and monitoring skills. The job doesn't end when a pipeline runs. It continues with ensuring reliability and uptime. Learn to implement monitoring, altering, and logging for your data systems. Tools like Prometheus, Grafana, or CloudWatch help track performance and failures. Additionally, incorporate data quality checks using tools like Great Expectations or Monte Carlo to ensure the accuracy and consistency of ingested data. A mature data platform engineer sets up systems that self-monitor and self-heal. Becoming a data platform engineer isn't about mastering a single tool. It's about building a holistic understanding of data infrastructure, automation, and governance. Start small, learn SQL, practice Python script, then move towards building pipelines and cloud data architecture. Over time, you will develop the expertise to manage complex data ecosystems that power real world decision making. The future of data engineering lies in scalability, in automation, and intelligence. As a data platform engineer, you will be at the center of it. So, if you need any help, if you need any help in understanding any term or getting resources for these different technologies, You can contact us at Slidescope or you can comment in the comment section below. Thanks for watching this. Have a nice day.